Hello everyone. We now continue our discussion about polynomial approximations and interpolations. So this will now be the part 3. So this is the previous activity I have discussed, and we now proceed with the next interpolation formula. Okay, so after the Newton's divided difference formula, we now proceed with the Lagrange interpolation formula. Okay, so this was named after the French mathematician Joseph Louis Lagrange, no? Who lived from 1736 to 1830. No? And to approximate the value of the actual function, the Lagrange interpolation formula can be applied. No? So here's the Lagrange interpolation formula. So we have here f of x. No? So f of x is the actual function is approximated by this uh, it is approximated, no, using Lagrange interpolation formula. So this is now the Lagrange interpolation formula, as you can see. Okay, so don't worry, it's not that difficult to memorize the formula. So here's the hint. No, so we start with, so f of x approximately equal to, okay, in always remember, if we are interested with this with the value x, we are to evaluate the function at a certain value x, so that x value is always written in the numerator. So we have x minus x of 1, x minus x of 2, and so forth. Now, considering the first term, so this is the first term. Okay, considering the first term, so this is the first term. Okay, so we start with x sub 0. Okay, we start with x sub 0. So we have f of x sub 0. And then, as you notice here, we, we have x. And below it, we have x sub o. Okay, so all x values in the numerator, okay, when it comes to the denominator, all of those x values will become x sub o values. Okay, so will become x sub o values. So take note that x sub 0, x sub 1, x sub 2, etc. can be viewed in the table, no? In the given table, no? For the function. So we have x minus, so we have x minus x sub 1, x minus x sub 2, and so forth until we reach x minus x sub n. As you notice, we don't have x minus x sub 0. Okay? We don't have x minus x sub 0. Okay, we don't have that. So that is the rule. If this is f of x sub 0, okay, so it is not advisable to have x minus x sub 0 in the numerator. Likewise, it is also not advisable to have x sub 0 minus x sub 0 in the denominator. So x sub 0 minus x sub 0 is prohibited. Okay? So that is a violation to the formula. Okay. Now, knowing that, we now proceed to the second term of the formula. Okay. So proceeding with the second term. So here's the second term. Okay, we have this. So we have the second term, and in this second term, so we're done with x sub 0. We now proceed with x sub 1. Okay? Now, same, all x values in the numerator. All x values. So this is all throughout. Okay? Considering all of the terms. So that is always the same, no? Written in the numerator. Okay, for all terms of this function. Okay? Of this equation. Now, in this case, since this is x sub 1, okay, when it comes to the denominator, we replace x by x sub 1. Okay, so x here will be replaced by x sub 1. Okay, because this is x sub 0 in the first term, so x is replaced by x sub 0. No? So, likewise, if this is x sub 1, all x values will be replaced by x sub 1 values. Okay, so we have x sub 1 values. And take note, we do not write x minus x sub 1. Okay, so we do not write x minus x sub 1. It's not allowed. Okay, x minus x sub 1 is not allowed. Likewise, x sub 1 minus x sub 1 is also not allowed. No? It's not allowed to indicate, no, in this term. All right. So if this is x sub 1, we're not allowed to have x minus x sub 1, x sub 1 minus x sub 1. If this is x sub 0, we're not allowed to have x minus x sub 0 and x sub 0 minus x sub 0. That's the restriction. Okay? That's it. I hope you get the pattern. No? So moving on with the third term. Okay? As you notice, this is x sub 2. All x values will be replaced by x sub 2. And we will not have x minus x sub 2. Okay, as you notice, there's no x minus x sub 2 in the numerator. Likewise, in the denominator, there's no x sub 2 minus x sub 2. So that's the rule. Okay, for x sub n minus 1, okay, so as you notice, if we have a table, let's say this is our table, we have x, f of x. So we start with x sub 0, followed by x sub 1, x sub 2, until we reach x sub n minus 1, then x sub n. Okay? So we start with x sub 0, okay, followed by x sub 1, followed by x sub 2, until we reach x sub n minus 1. Second to the last, x sub n minus 1, and lastly, x sub n. Okay? So that's the procedure. Alright? I hope you get it. No? So, considering x sub n minus 1, okay, so all x values here will be replaced by x sub n minus 1. Okay? And also, we're not allowed to have x minus x sub n minus 1. We're not also allowed to have in the denominator x sub n minus 1 minus x sub n minus 1. And then, lastly, we have x sub n. So for x sub n, we have, so all x values are replaced by x sub n Sorry. So all x values are replaced by, okay, x sub n. Okay, and then we're not allowed to have x minus x sub n in the numerator. We're not also allowed to have x sub n minus x sub n in the denominator. So that's it. So let's apply this formula with an example. So here is the problem. We are to compute the cube root of 4.4 from the following table of cube root of x. So suppose we don't have a calculator in finding cube root of 4.4. So we can able to apply the Lagrange interpolation formula to obtain the cube root of 4.4. So in here, 4.4 is replaced by x. Okay, so 4.4 is replaced by x. So we have x, and cube root of x is f of x. Okay, so this is f of x. So this is f of x. And in that case, no, so when we apply Lagrange interpolation formula, okay, we will approximate cube root of x to be a polynomial function. Okay, we approximate it to be a polynomial function applying the Lagrange interpolation formula. Okay, so that's the procedure. So we are to solve for the cube root of x applying the Lagrange interpolation formula. And in applying such, the function is approximated by a polynomial function. This is a radical function, right? This is a radical function, f of x, cube root of x. However, uh, applying the Lagrange interpolation formula, this is transformed, no? F of x is approximated, no? Approximated. Okay, by a polynomial function. All right. There. So because this is a radical function, no? It's a radical function. Okay. Now let's continue. So given if we have x equals to 4, that is 1.58740, right? If we have x equals to 4.5, the cube root of 4.5 is 1.65096, and so forth. So if we have 4.4, if we have 4.4, what's the corresponding cube root of x value? Since we don't have suppose we don't know, suppose we don't have a calculator, so we can able to solve the problem using the Lagrange interpolation formula. So cube root of x now is approximated by a polynomial function. Okay, so in that case, we have here the solution, no? So first thing to consider is we have to arrange the values of x in ascending order from lowest to highest. Okay, next step, we can replace this by x sub 0 until we reach x sub 4, the last value of x. And then we can proceed. So using the Lagrange interpolation formula, no? So here's the equation, no? Okay. Now for n equals to 4, we have f of x, okay, approximately equal to. So as you notice, n is 4, so this is x minus x sub 1. Sorry. So we have x minus x sub 1, okay, followed by followed by x minus x sub 2, okay, until we reach x minus x sub n, until we reach x minus x sub 4. So we have here x minus x sub 3, okay, that's it. Okay, then likewise in the denominator, x sub 0 minus x sub 1, x sub 0 minus x sub 2, x sub 0 minus x sub 3 until we reach x sub 0 minus x sub 4. Okay, and this is the same as in the second term. Okay, we have here x sub 1. Okay, so we are not allowed to have here x minus x sub 0. So as you notice, there's no x minus x sub 0 here. In here, we're not allowed to have x minus x sub 1. So as you notice, there's no x minus x sub 1. Okay? Likewise, in the denominator, there's no x sub 1 minus x sub 1. Okay? Same as x sub o. There's no x sub 0 minus x sub 0 in the denominator of the first term. Considering the third term, this is x sub 2. So we have, there's no x minus x sub 2 here. So there's also no x sub 2 minus x sub 2. Okay? And then third term, then last term. Okay? For the last term, so this is the last term. Okay, considering the last term. Okay? So we're not allowed to have x minus x sub 4. Likewise, we're not allowed to have x sub 4 minus x sub 4. Okay, so that's it. So this is now uh, the answer to our problem now. So since our goal is to find the cube root of 4.4, where x is equals to 4.4, so we replace x here by 4.4. Okay, so as you notice here, this is a polynomial function. Okay, so f of x approximately equal to this expression, no? So this is a polynomial function. Okay, now we replace x by 4.4, okay, and evaluating the polynomial function at x equals to 4.4. So we obtain the answer of 1.63863. So that is our answer, 1.63863. So that's it, no? So the cube root of 4.4 is 1.63863. Okay, so we may check our answer using calculator, no? So we may check our answer using calculator. So the cube root of 4.4, 1.63864. Okay, so as you notice, there is slight variation. We have cube root of 4.4 approximately equal to 1.63863. It's not exactly the same as cube root of 4.4 because this is just an approximation. Okay, so that's the use of the Lagrange interpolation formula. No? Now for your activity, simulate the solution in determining the value of f of a, considering the table as shown hereunder, using Excel, applying the Lagrange interpolation formula, such that when any tabular value of x or f of x is changed, a new correct value of f of a is obtained, where a not found in the table is any real number between x sub 0 and x sub n. Okay, so let me discuss this problem, this activity. So in this case, we are to simulate the solution in determining the value of f of a. So where a is not found in the table, it is any real number. Okay? It can be rational or irrational. So meaning it can be a decimal number or an integer. So between x sub 0 and x sub n. So this is, we know this is x sub 0. So we know that this is x sub 0. And we know that this is x sub n. X sub, this is x sub n, where n is equals to 0, 1, 2, 3, 4. So n is 4. Okay, so this is x sub 4. So this is x sub 4 there. Okay, now between 4 and 7, okay, a not found in the table, where a is between 4 and 7, not found in the table. So it can be, let's say, 4.4, right? So let's say 4.4. So this is a. A is 4.4, no? So what is f of 4.4? So what is f of 4.4? So what's the value of f of 4.4? So we solve it, no? Using the Lagrange interpolation formula. Okay? And the answer should be in my previous slide. In my previous slide, 1.63863. That should be the answer. Okay? That should be the answer. Now, how about if I change it to 5.7? What is f of 5.7? Okay. So, you have to determine the answer also, no? So, it depends upon the manner and how you solve the problem, how you simulate. Okay? So, that is your goal. Okay? If I change the value of a, let's say I changed it to 5.7, I should have, Okay, I change it to 5.7. Okay, I should have also a correct value. That is my objective. Okay, I should have also a correct value. Okay, so that is my objective. No? So when any tabular value of x or f of x is changed, okay, a new correct value of f of a is obtained. Okay, let's say I change this to 3. Okay, so I will have a new correct value of f of a. Okay, which is f of 5.7. So if I change this to 9, I will have a new correct value of f of a. Okay? Okay, so this is what you will do. So, so the instruction is to simulate the solution of the given problem, no? So simulate the solution in determining the value of f of a, no? Considering the table as shown here under. Okay, so applying the Lagrange interpolation formula. So such that when any tabular value of x or f of x is changed, a new correct value of f of a is obtained. Okay, so this is f of a. Okay, actually this is a. X equals 4.4. This is a. Okay, so this is not found in the table. No, so 4.4. Okay, this just we are just approximating the value of f of x at x equals 4.4. So meaning x equals to 4.4, that is a is equals to 4.4. Okay, and in this case x sub 0 is 4, x sub 0 is 4, x sub 4 or x sub n is 6. Okay, x sub n is 6. Okay, and then so I apply the Lagrange formula. Okay, so here's the I simulated it, no? So so in this case, this is what you will do. So you should arrive with this answer. Okay, and after that, now suppose I want to change the value of 4 to 2. So automatic magbabago to, 2 na yan. Okay, automatic magbabago na rin ito, 2 na yan, x sub 0. At napalitan yung value. Dahil naging 2 yon, yung x sub 0, okay, yung f of 4.4 naging 1.638956. Okay, so ganun lang yung gagawin nyo. So halimbawa, ito naman yung napalitan. So dapat tama pa rin yung sagot, syempre. No? Let's say halimbawa, 1.9. Okay, ginawa akong 1.9. Okay, tapos pwede ko rin baguhin to. No? Pwede ko rin baguhin yung x ko. Basta in between 2 and 6, pwede kong gawin na 5.8. Okay, 5.8. Okay, 5.8. So, bibigay niya yung tamang sagot. No? So, A is equals to 5.8. Okay, hindi siya lumagpas ng 6, between 2 and 6. No? 5.8. So, 1.918301. Check nga natin kung in between. 5.8 at saka 6. 5.5 and 6 sa table. Sa table, 5.5 and 6. 1.9, 1.8, 1.7, 1.2. So, ano yung binigay niya? 1.918301. Okay? 1.918301. Okay, so ganun yung binigay niya. Alright, so I hope you get it, no? Okay. So, ganyan yung gagawin nyo, class, no? So, simulate nyo using the Lagrange interpolation formula. Alright? So, just follow the instruction, no? Okay? So, dapat automatic tama yung sagot pag nag-change ako ng mga value sa Excel file ninyo. Okay? So, that's it. Good day, everyone.